the second part of this section, you need to understand that if the degree on top is the same or higher than the degree on bottom, there is no way to integrate that, that rational function unless you either use long or synthetic division to split it up into different pieces. So, we're going to look at the integral of x squared plus x plus 1, all divided by x squared plus 1. Do you see how it has the same power on top and bottom? But in the other ones, the highest power was in the bottom. So that's not an issue when the highest power is in the bottom. The problem is when the highest power is equal, if they're equal or it's on top. You need to split it up. And let me make sure that you can see why. If you tried to do this the other way, if you try to just go ahead and bring that denominator up, you don't have what you need to sacrifice. I mean, you would need to give away a 2x, and you have an x squared and a plain x, but you wouldn't be able to give away all of this. And you can only, put a natural log on this if you can give away all of that. So you're kind of just locked in a bad situation. The second thing I need to make sure you understand is when you can and can't use synthetic versus long division. Remember that if you're dividing by a square or higher, you can't use synthetic division. You can only use synthetic division if this was like x plus 1, not an x squared plus 1. So we're going to be forced to use long division on this guy. So we'll take the x squared plus 1, and we'll divide it into x squared plus x plus 1. And then we ask ourselves, what do we have to multiply the first thing here by? And to make it equal the first thing here. And that's just a what? Just a 1. So we'll put a 1 up there above our constant. And then you multiply this 1 by both of these. And then you draw a line, and you change both of those signs. And bring down what's left. So we're left with x. Now, can I keep going, or is that going to be my remainder?
That could be your remainder.
That's going to be my remainder. Once the power here drops below here, then you're looking at a remainder. Okay, so this problem can be broken up into 1, which is this guy, plus this remainder over the divisor. So take a look and make sure you understand what we did. It's always going to be the quotient plus the remainder over the divisor. Now, because it's split into addition, you can do that as 2 separate integrals. So we are going to integrate 1, and we're going to integrate x over x squared plus 1, but I'm going to pull this to the top. And you're allowed to do that because the higher power is in the bottom. Is everybody okay so far? I know you probably don't like it, but once you do a few of them, it's not that bad. Okay, what is the integral of 1? Just plain x, right? And then we have to integrate this next piece. And to integrate this, I need to give away a 2x, right? But I only have a 1x. So I'm going to insert a 2 and balance it with a 1/2. And give that to the volcano. And then see how this is a negative 1? That's why it's in this section. When you integrate your remainders, they're going to become natural logs. So the natural log of x squared plus 1. Plus c. Oops, thank you. I left off the 1/2. Okay, so we started here. We did long division. We got our quotient and our remainder. And we integrated the quotient plus the remainder over the divisor. And remember that every time you integrate that remainder, it's going to show up as a natural log. But the other piece, the quotient integral, won't. It'll just be a regular integral. Okay, let's try one where you have to do synthetic division, or you can do synthetic, just to review that. And then we'll stop for the day and pick up next time. So for this last example, we have the integral of x cubed minus 6x minus 20 divided by x plus 5. And because the power is higher on top than on bottom, remember that if they're equal or higher on top, you have to divide it out and split it into separate integrals. Because we're dividing by x plus 5, not x squared plus 5, we can use synthetic division. So let's review that real quick. remember that you take what makes the denominator 0, and it goes in your little synthetic division box. And then right here you list the coefficients of the numerator, which in this case is 1, 0, -6, -20. We have to put that 0 in there because you have to have a placeholder for every power. And since we don't have any x squareds, we have to put a 0. Then we multiply these two, we get -5, you add those. And you multiply again, and then you add again. And you multiply again, and you add again. This gives you, this guy right here is your remainder, and these guys are the coefficients of your quotient. So we will bring our x's back, and that will give us 1x squared. Remember that it starts 1 power less than it was before you divided? Because if you do x cubed divided by x, you get 1x squared. Okay, so that gives us x squared minus 5x plus 19 minus 115 over x plus 5. So far, so good? Okay. Now, this is what you have to integrate. And the best way to do that is to split it into only 2 integrals. Integrate the quotient and then do a separate integral for the remainder part, because that's going to be the only part where you're going to have to worry about any sacrifice. Okay, so we're going to do integral of x squared minus 5x plus 19. And then we're going to subtract the integral of 115 over x plus 5. So this piece right here integrates to x cubed over 3 minus 5/2 x squared plus 19x. You can just do the power rule on each of those. This next part, however, we need to bring this to the numerator. So we'll have 115 x plus 5 to the -1. And the nice part is, what's my sacrifice? Just a 1. So just a 1 dx. So we'll bring down the rest of it. And that'll just be our coefficient minus 115. And then this will become a what? A natural log, because it's to the negative power. -1 power. If it were anything else, we could do the power rule. The -1 power turns into the natural log of the absolute value of x plus 5. And I'm out of room, but we need a plus c. There we go.